All right, kiddos. I'm going to teach you how to use two different rules today. They're called the product and quotient rules. So the first thing to understand is for our notation today, both functions we're going to say call them f. I'll make it a little bold. So f and what we'll refer to as g. So those are both functions, right? Those are going to be functions of x. Okay, meaning that they have an x in them, right? They're not just numbers, they're not constants. Okay, so the product rule says this. Okay, if I want to differentiate the product of two functions, both of which have an x in them. So if I want to differentiate f times g, right? And that's how I'll use that notation. There's a rule I'm going to use, and it's called the product rule. It's not, surprisingly, it's not the derivative of f times the derivative of g. It is equal to, in fact, the derivative of f times g plus f times the derivative of g. Okay? And this guy right here is our product rule. Okay? So in order to find the derivative of a product of two functions, right, f and g, okay, I first differentiate the first piece, the first factor, times the plain old second, plus the first piece times the derivative of the second factor. Okay, that's called the product rule. Now, let me give you a couple examples. Okay, what if I asked you to differentiate the following function? What about 3 sine of x? Okay, so that's certainly a product, right? And your first factor is 3, there's your f. And your second factor is sine of x, there's your g, right? But in this case, 3 is not a function of x. It's just merely a coefficient. So I'm not going to use the product rule for this. I'm going to use our coefficient rule, right? And our coefficient rule says it's going to be 3, which is a coefficient, times, and now the derivative of the sine function, right? And the derivative of the sine function, of course, is cosine x. Okay, so in that case, no need, although we could, but no need to use the product rule, right? We already know how to deal with a coefficient times a function, right? But the product rule is going to help us with this problem, okay? And in this problem, you can't use the coefficient rule, right? So this problem, what if I asked you to find the derivative of 3x times sine of x, okay? And to make it a little clearer, we'll put a little times right in the middle there. Where is that little times thing? Come on, man. So here it is, bam. Okay. So for this particular problem, we don't have the luxury of using the coefficient rule because 3x ain't a coefficient. It's an entirely different function of x, right? So for this case, I have to use the product rule, right? And so when I have two functions, f, 3x, and g, sine x, that I'm trying to differentiate, what I'm going to do is I'm going to take the derivative by rule of the first piece, right? So what's the derivative of 3x? 3, that's correct. Times just g, times the second piece, which is just sine. Right? I'm going to add to that the first piece, right, which is just my f, the first factor, times the derivative of g prime, or the derivative of my second piece. And the derivative of my second piece, which is sine of x, the derivative will be cosine. Okay? So note the difference between this particular problem, 3x times sine x, and this problem, 3 times sine x, right? For the first one, I use the coefficient rule, and although I could use the product rule, I don't need to. It makes it much harder to do so. Okay, 3 is a coefficient of sine of x. Whereas in this case, 3x is not a coefficient. Coefficient is a real number. So 3x is a function, and sine of x is a function. And so when I'm differentiating the product of 3x times sine of x, I use the product rule. Right? The derivative of the first, 3, times the second, sine x, plus the first, 3x, times the derivative of the second, cosine. Okay? That's the product rule. The next rule is called the quotient rule. Right? And the quotient rule, much like the product rule, deals with differentiating product of function. Quotient rule deals with differentiating the ratio of two functions. So I'll write it out really quick. So I want to take the derivative with respect to x. Oops. of the ratio of two functions. Okay? Not two numbers, two functions, both an f and a g. And f has an x in it, and g has an x in it. Right? And so, in order to find this, and it's not surprisingly the derivative of f over the derivative of g, but it is in fact the following. It's a little bit of a handful. So it's going to be g, which is low, the denominator, times d high, the derivative of the numerator, minus f high, our numerator, d low, the derivative of the denominator, g prime, all over low, low, all over our denominator squared. Okay? And a way to remember this is, as I was taught long ago, a little phrase that we can use is low, low being the denominator, g, times d high, right, the derivative of the numerator, minus high, our numerator, times d low, the derivative of the denominator, all over low, low. Right? So you have low, d high, minus high, d low, all over low, low. That's a way to remember it. Right? So the derivative of f over g, both f and g are functions of x, is going to be g low times f prime, d high, minus high, f, d low, g prime, all over low, low. Okay? And again, I'll give you an example, one where we are going to use it, one we're not, and we'll start looking at a case where it looks like we might use it, but we're not. So just like we do the product rule. So let's take a look at this one. What if I ask you to find the derivative of, and let's say, I don't know, cosine x over 4. Okay, so I want you to find the derivative of the cosine of x over 4. Well, I'm not going to use the quotient rule, even though it is in fact a ratio. But it's not the ratio of two functions, right? In fact, there's a much easier way to do this problem, and it's going to be the same as the derivative of, right? So I'll just use a little nifty algebra, and I'll just call that, instead of cosine x over 4, I'll call it 1/4 times cosine x, because that's what it is, right? This is the type of problem we have been working with, right? So to differentiate 1/4 times cosine of x, I just use the coefficient rule. The 1/4 is a coefficient of cosine. It comes along for the ride. And then times the derivative of cosine. Of course, the derivative of cosine is negative sine. So I'm going to put the negative out front and put the sign out back. Okay. So no need to use the quotient rule to differentiate cosine of x over 4. Okay, but what if I ask you a very similar problem to differentiate cosine of x over, let's say, 4x squared? Okay, then it becomes a whole different ball game. So now let's find the derivative with respect to x of, instead of cosine x over 4, let's make it cosine x over 4x squared. Ooh. Okay, so now we have to use the quotient rule, right? Because unlike the previous case where we have just over 4 or times 1/4, in which case a 1/4 is a coefficient, and I can use a coefficient rule times the derivative of the cosine. Right here I don't have a coefficient to pull out. In fact, I have a function of x up top and I have a function of x down low. So if that's the case, I have to use our quotient rule up here, which says, right, what I'm going to do is I'm going to take the derivative of high over low, and that's going to be low, and low is just 4x squared. D high is the derivative of my numerator, right? And the derivative of my numerator, which is cosine, is negative sine x. So here's my low, which is the denominator, times the derivative of my numerator, d high, minus high, which is my cosine of x, d low. Now what's the derivative of 4x squared? No, it's 8x. All over low, low, all over 4x squared. So when I square 4x squared, I get 16x to the 4th. You're correct. Okay. And I can clean this up a little bit and make it look a little prettier. Although they're not that much. And so what I'm going to do is I'm just going to rewrite my numerator as negative 4x squared, time for lunch, times sine x, minus, we like to put the 8x in front, times cosine x, and that's all over 16x to the fourth. And then we can manipulate that even farther by factoring out. Anybody? What can we pull out of each term? Well, yeah, a 4x, and so I can pull a 4x out of everything if I so choose. And that's going to end up looking like, anyone? If I pull a negative 4x out of negative 4x squared, I get a negative x sine x. If I pull a 4x out of negative 8x cosine x, I get a 2 cosine x. And then I pull a 4x out of the denominator, which leaves me with a 4x to the third. Okay? And so here's my little simplification here, which is usually, as far as the algebra is concerned, a little messier than the actual differentiation. Okay? So again, let's focus on the difference between the first example, where we can use the coefficient rule, and the second example, very similar looking but different, where we have to use the quotient rule. The quotient rule says take the low, 4x squared, d high, derivative of cosine x, minus high, cosine x, d low, for derivative of the denominator, which is 8x, all over the denominator squared, low. Okay, then we clean it up a little bit. Okay? All right, your turn. What I want you to do tonight is the following two problems. Okay, number one, find me the derivative of let's call it root x times sine of x. Okay, got to use the product rule. All right, and then the second one, I got a little quotient rule. You have to use the quotient rule here. Why? And I want you to find the derivative of 3x to the fifth over, let's make that over 2 sine of x. Okay? All right, two problems to do. Have fun. Product rule the first one, quotient rule the second one. Bye-bye. Again, here are your rules. Have a great night. We'll see you tomorrow.